Hey, how's it going? It's Simon. In this video, we're going to be going over some kernel examples. So for this first problem, we have this kernel over here. And what we're going to do is first, since this is a kernel, we're going to set this matrix equal to 0. So we're going to create an augmented matrix. So we're going to just copy everything over the same as it was before. But we're also going to add this row of zeros right here. Now we just need to row reduce this matrix. So what we're going to do is we're going to subtract from R2 just R1, and then from R3 we're going to also remove R1. So we're going to get in our daily row reduce. So we get 1, 1, 0 here, and then here we're going to get 0, 1, 2, 0, and then here we're going to get 0, 2, 4, 0. So right away I can tell that this row is a multiple of this row, so something's going to be canceled out. So next we're going to do let's say R1 minus R2 and R3 minus 2R2, and what we're going to be left with is 1, 0, negative 1, 0 with 0, 1, 2, 0, 0, 0, 0, 0. So as we remembered, this row this column represents x1, this is x2, and this is x3. So we can see that for this matrix, x1 is going to be equal to x3, and x2 is going to be equal to negative 2x3. So we can group this whole thing into one vector. So we can say that the kernel of A is going to be equal to, so also we should add here that x3 is going to be equal to x3, and this is our free variable, so x3, and then we can just do 1, negative 2, 1. So our kernel for A is going to just be this vector over here. So it can be made up of just this vector. So on to the next one. For this next example, we have something that's a little bit different. We have a 2 or a 3 by 2 matrix. So we do the same steps to start off. We're going to create an augmented matrix. And then we're going to subtract R1 from R2 and R3. So R2 minus R1, R3 minus R1. And we're going to get this equation right here. We're going to get, or this matrix right here, 1, 0, 0, 0, 1, 0, 0, 2, 0. And just like in the matrix above, or in the example above, I can tell right away that this is row 2 is a multiple of row 3. So let's do R1 minus R2 and R3 minus 2R1, and we're gonna get 1, 0, 0, 0, 1, 0, and then 0, 0, 0. As we see, though, every column has a leading 1, so we're just going to have x1 equals 0 and x2 equals 0. So the kernel, so this is where the solutions will occur. So the kernel of A is just going to be the set that is the 0 vector. So it'll only have one solution. That's when everything, or these two items are 0. So yeah, we went over 2 examples of getting the kernel. So it's a pretty straightforward process. We just take the original matrix and then we set it equal to all zeros, and then we find the reduced row echelon form, and then we see what the solutions are, and whatever the solutions are, that is our kernel. So great, hope you enjoyed that one.